Hello everyone, it's Mr. Elvin from ASUS Math, and today I'll be going through a quick question on exponential models which illustrates the application of the exponential equation today. So the exponential model is generally used to model population growth or decay, whether is it increasing or decreasing, and we will see how it comes into play today. So what I have here is an equation describing the population of bacteria at any given time in terms of hours, where A and B are constants but unknowns right now to be solved. And we are given two pieces of information. That is, when the observation started, the population of the bacteria was 1,000, and 5 hours later, it will be 10,000. Now, whenever I see this, I always translate them into its mathematical form right away. The first piece of information tells me n is equal to 1,000 at t is equal to 0. The second piece of information tells me n is equal to 10,000 at t is equal to 5. Since the time step indicated by the model itself is in terms of hours. So there we have a pair of simultaneous equations that we can actually use to solve for A and B. So, making use of the first piece of information, we thus have 1,000 is A, B to the power of 0, which is equal to A actually. So whenever we have solved for the value of one constant, we will update the immediate equation right away, and we thus have n is equal to 1,000 b to the power of t now. Substituting the second piece of information in, we have 10,000 is equal to 1,000 b to the power of 5, which means that b to the power of 5 is actually just equal to 10, and b is 10 to the power of 1/5, or equivalently 1.58 at 3SF level. Alright, with this, I will always make a habit to update my master equation right now to solve any subsequent parts of the question. Hence, the population model is actually indicated as n is equal to 1,000, 1.58 to the power of t. Alright. Now, for part B, it becomes a straightforward situation. Given that the bacterial size is now 5,000 in population, what is the time taken to reach there? And we thus have 5,000 is equal to 1,000, 1.58 to the power of t, which means that 5 is equal to 1.58 to the power of t. Sorry for that. And t is thus ln 5 over ln 1.58. And we have 3.52 hours, giving us, in terms of minutes, 211. Okay? So, for part C, it's a clear, simple substitution procedure again. What is the population of the bacteria when we are at 12 hours, and that is when t is equal to 12. So, it becomes a simple substitution again. When t is equal to 12, n is simply 1,000, 1.58 to the power of 12, giving us a value of 242,000, and 2 in 3SF, we have this. Alright, so this is the key to solve such questions. All you need to do is be able to interpret and translate between the English information and its mathematical form. Whenever given a piece of information or sentence, always ask yourself, what is the question actually seeking or trying to tell you mathematically? And once you have this awareness and being able to translate between these two forms in a very versatile fashion, you will not have any more issues with this subtopic anymore. Alright, that's all from me today. I wish you all the best. Take care and goodbye.